integrated ordinary differential equations to get a closed form solution. And those methods give you exact solution, within quotes, exact solution. For example, if you have a second order linear ordinary differential equation, you know how to get the complementary function and particular integral. Are you familiar with these terms? You're not familiar? Let's see, if I give you mx double dot plus kx equals sine omega t, you don't know how to get a solution for this one?
Actually, sir, differential equation hasn't been taught to us yet.
Okay, okay. Now, now of course, this may not be familiar to you, okay, but you are familiar with this one, right? You know how to integrate this one, right? When the equation is homogeneous,
Yes, sir.
the solution is a simple harmonic motion, right?
Yes, yes.
Okay. Now imagine if I change this x to sine of x, then what happens? It still remains a second order ordinary differential equation, because there is only one independent variable, and that is time. And because it is the independent variable is time, so it's an initial value problem. What is an initial value problem? So every time you have a differential equation in space, that is called a boundary value problem. And every time you have a differential equation or a differential equation in time, it's called an initial value problem. Because when the problem is given in time, you can only know the initial conditions. So for example, you can know that x equals, let's say, pi by 4, and x dot equals 0. I'll explain the situation. Imagine there is a simple pendulum, and this angle, you take it to be x. Okay. And if you release from certain conditions of at t equals 0, x is so much and x dot is so much, that is the initial condition. And if you release from this condition at any instant, so of course there is mg going downwards, and then there is t. But then if you solve the equation in two directions, one is the x direction, and let's say this is the radial direction, right? So x is basically your theta. So this is the radial direction. So if you take all the forces in x direction, so that would be minus mg sine theta. Okay. And that should be m times x double dot. Sorry, not sine theta. This is sine of x. It is not x double dot. It is m times a, and acceleration in x direction, and acceleration in x direction is going to be L times x double dot. So finally, when you write this equation of motion, it becomes mx double dot plus g by L sine of x equals 0. Okay, mg divided by L. So finally, of course, you can cancel the m's from both the terms, but this right here is like this constant k over here. Okay, and that's actually the actual equation of motion of a pendulum, simple pendulum. Now, of course, we take it to something like mx double dot, or rather x double dot plus g divided by L x equals 0, and eventually we say that x is something like c0 cos omega nt plus c1 sine omega nt, where omega n is essentially the square root of g by L. We know that it is going to perform a simple harmonic motion. But how do we get here? We assume that x is many times smaller than pi by 2. So much small that sine of x tends to x. Basically, x tends to 0. And practically, x is less than whatever is the radian value of 5 degrees. So in such a situation, you can linearize this equation. And you have an ordinary differential equation which is second order but also linear. Second order ordinary differential equation, homogeneous at that is the right hand side is 0. Okay, but essentially you have a linear ODE, and that you can directly integrate. This integration right away you can do because it's a linear ODE. Okay, now just think of the actual equation of the simple harmonic, not simple harmonic motion, the motion of a simple pendulum. That is not a linear differential equation, and that actually you cannot get like this one right here, a closed form solution. This is called a closed form solution, an exact solution. That means if you can evaluate cos of omega nt and sine of omega nt with correct precision, you get accurate values of x to that precision. Okay. So when you have a nonlinear equation in hand, and this is just one of the examples, one of the many examples or many situations where you need numerical methods. So when you have a nonlinear ODE in hand, then you cannot get an exact solution. So you'll have to employ some numerical integration in this case, or in general, a numerical method. Because I mentioned there are a lot of different situations where you need to work with numerical methods. For this one, you need numerical integration. So you need numerical methods. And numerical methods, the very essence of numerical methods is errors, because these are approximate solutions. And every numerical method, every time you learn a numerical method, you also learn about ways to improve accuracy. Actually, every numerical method should be devised in a way that if you keep on doing improvements over the method, okay, then you can get higher and higher accuracy. And what do I mean by improvement? For example, think of evaluating something like this. E to the power minus x squared, running from minus infinity to infinity. Okay, but let's say you are only interested in integrating it from a finite limit a and b. Now, I don't know whether you can get a closed form solution of this one. Okay, but it would be a lot simpler to simply plot this quantity, which I believe on the positive side should look like this. Yeah, yes. So it basically is a bell-shaped curve, as you know. This is basically a Gaussian distribution. And we use that in probabilistic model known as normal distribution. So you are trying to do this integration from A to B. And no, this A and B are not minus infinity to plus infinity. Then you have a closed form solution. That integration is a constant. But let's say for any arbitrary value of A and B, to be able to evaluate this for arbitrary values of A and B using closed form solution, it means you should be in a position to do indefinite integral on this quantity. That means you should be in a position to integrate this quantity like this symbolically for arbitrary values of A and B, or for that matter, you should be in a position to give me that function that you get something like this. Now, what I can do is I can do a lot of approximations. Okay, and in a later class, we would learn about something called trapezoidal method. Where for a starter, I can of course evaluate this quantity at A and evaluate this quantity at B, right? So I can take those two values, make a trapezoid out of it, and the area of the trapezoid is essentially 1/2, and then sum of the parallel sides, that is f A plus f B, and then B minus A, right? So you see, it's an approximate method. Okay. But then I can improve on this method, right? Instead of taking a single trapezoid, I can take another intermediate point. Let's call it x1. So A is like x0, B is like x2, and let's take another point x1. And you can probably visualize this thing, that by taking this, I'm almost able to match, or able to match the curvature of the not the curvature, but at least approximate the area under the curve much more accurately than the previous example with a single trapezoid. Okay.
Yes, sir.
So
then we can make multiple sections like x1, x2, and x3. That would give us more.
Yes. And in the limit, if I take infinite number of sections between A and B, I'll be getting the exact solution. Okay. So the thing is, the idea is numerical method does have error. Error is never zero, but there are also ways to improve the error or to minimize the error. Now, of course, it's a trade-off between the computational cost and the accuracy. Is going for 50 steps in this case if A and B are not that far, and if the curve that is there is not in the curve segment between A and B has very little curvature. In that situation, is it worth taking 50 segments between A and B, or even 500 segments? So that is a judgment. That is, of course, for the user to make. But the fact is, you always think about two things: how much would be the computational cost, how much time would be required for computing that value, and the other one is how much accurate are the results. Okay. Now these are just examples. So in this class we are going to learn about numerical methods. Okay, but today we are not doing integration of ODEs. We are not doing integration of a given function, a given integrand. It's an entire ODE, and here you have a function. We are not doing any of that. Now, of course, there are a lot of things like numerical differentiation that we would learn in this class. Today, I have planned to, this topic. I have planned this topic for today's class, and that is curve fitting. Okay. Now,
Okay, sir.
now, I did a mistake. So since your class were supposed to start after 23rd, so I planned on giving because your class started this week. I planned on giving you one assignment. Okay. So I believe all of you by now, either in your school or in your undergrad math courses, have already learned about that little thing called least square line fitting. Have you?
Sir, could you illustrate this one, missed square line fitting?
You are not familiar with least square straight line fitting?
So if you could tell us, just give us an idea of it. Maybe we have heard it in some other name.
Okay. So anyone who has taken statistics, did you have a course on statistics on this curriculum of yours?
No, sir. No.
Okay. So I wanted to give you that assignment because it's a very small part of curve fitting, and I actually started giving you a class assignment, and that day I lost my internet connection, and I thought I had given you, but now I realize I didn't. So it's okay, since you have not done anything related to curve fitting. Let's start afresh. So if you might have seen this, right? If you might have required to plot certain X versus Y data, I don't know what, maybe force versus deflection or anything by now, right? Or let's say voltage versus current or anything. Okay. So anything that you plot, let's say an experimental result, so that would be some scatter of points, right? Scatter of experimental data points. Now, if you take a very tiny segment of that, okay, so you can imagine a best fit line that would correctly represent the trend or the variation of Y versus X data, right? So here we are talking about least square. Now I will explain what is least square a little bit later. Least square method of fitting a straight line. একটা জিনিস বলে দিই, ক্লাসে যারা রয়েছে ইদানিং দেখছি সেশনাল ক্লাসেও কয়েকজনের অভ্যেস হয়েছে ক্লাস চলাকালীন মাঝপথে বেরিয়ে যাও। আগের থেকে সাবধান করে দিই, এই ক্লাসটাতে বেরিও না। প্রথমত হচ্ছে যে একটা জিনিস, সেটা হচ্ছে তোমরা তোমাদের অ্যাটেন্ডেন্সটা চ্যাট বক্সে দিতেই পারো। And the thing is, because it's a sessional class, I'll be giving you spot assignments. Okay. And what you can do is, once you are done solving it, Okay, I can share you a link in the classroom and you can directly upload it there while the class is going on. And I might be giving it one of them today. Okay, tiny assignments and maybe some more for submitting by the end of the day. I mean, what you can let's say the programming part I'll let you do let you submit in one day. Okay, তো তো বেরিয়ে গেলে যেটা হবে ওই অ্যাসাইনমেন্ট গুলো সাবমিট করতে পারবে না। আচ্ছা, তো so we here we are learning about how to fit a straight line. Okay, now how do I know which line is the best line? Is it this line or is it this line? Okay. There should be some standard, some norm for you to know that that which one of them should be treated as the best fitted line. Of course, there could be different methods, but here we would consider the least square method. Okay, and the norm in the least square is this thing written as delta squared. That is basically the sum of where n is the number of data points. So like P1, P2 up to Pn. And what are Fi? So you are trying to fit a function something like this, right? Mx plus c. You are trying to fit f of x equals mx plus c. So for every, so data points are basically, these are your data points, x versus y data, right? x1, y1, x2, y2 up to xn, and then you have yn. Okay, so there are n data points. So I want to minimize this quantity. Okay. Now, one question that you should ask in the very beginning, whether I should be trying to fit a straight line. That means whether the data set actually represents a straight line. Now, let's say if you are, sorry?
No, sir, nothing, sir.
Okay. But let's say you are doing an experiment, okay, where you are applying voltages and noting the current to measure the resistance of a given component. Okay. Now you can more or less assume. Of course, there are temperature effects. The resistivity changes with temperature. Temperature changes with electric current. But you can more or less assume that the voltage and current variation should be more or less linear. Okay. So it also depends on your judgment, whether you are trying to fit a straight line or a parabola or an exponential line or a power law. An exponential line would be something like e to the power bx plus c or something. So that basically means it is something like y0 e to the power bx. Okay. A power law fitting would be something like y equals a times x to the power b. Okay. And even a logarithmic fit. Okay. So there could be a power law situation. There could be an exponential law. I mean, you do not know which one of them is the best representative of your data. Okay, but I mean, in general, you do not know. But if you have some knowledge about the physics, and if you can identify the trend, then then you can go for whichever of this representations is the correct representation, and you can fit accordingly. And at this point, I should also clarify that, let's say there is an exponential rule, so I can say that ln of y is ln of y0 times b times x. Now, in some way, this can be treated similar to, if there is a way for me to fit a straight line, I should be in a position to fit this type of behavior as well. If I am equipped with a method that allows me to fit a straight line through a set of data points, if required, and if I think this is the correct trend, then I should be in a position to fit this type of behavior as well. All I have to do is replace y with ln of y and keep x as it is.
Yes, yes.
And then I have a straight line fit.
Yes, sir.
Okay. And if you look at this power law, that also, if I do ln of y, it is ln of a plus b times ln of x. So what do we do here? Okay. So I can fit a straight line or a very nonlinear type of curve. Okay. And least square is a general method which allows me to do that. Okay. Now let's dig into the details of least square method. The reason why I cleared this up at the very beginning, because I would be covering how to fit a straight line, and I would be expecting you to be able to fit this type of nonlinear trends if required. Okay. Achha, you might have some experience. Some of you might have some experience with doing any of this, fitting a straight line or fitting a power law or a exponential fit in Excel. Have you done it on Excel sheet? Anyone? To a set of data points?
No, sir.
No, sir.
No, sir. No, sir.
It's okay. It's fine.
No, sir.
It's fine. But today, when you go back after this class, okay, you might have done some experiment in your curriculum, be it electrical lab or physics lab. Okay, take that
Yes, sir.
data. Okay, and you should be in a position. I mean, you don't need any skill. You can simply put those data in Excel sheet, and in Excel, once you do a scatter plot, okay, literally the scatter plot, then you can right click on any of those points, and then it allows you to fit a trend line. And there are different ways of fitting a trend line. Okay. So different types of trend lines are available. For example, there are linear trends, there are this exponential and this power law trends, and there are certain polynomial trends as well. Okay. There is also a logarithmic trend. The logarithmic trend is simply the reverse, which basically is this quantity x equals 1 by b ln of y minus ln of y0. Okay. Now, if you are trying to fit x versus y, not y versus x, okay, and you are trying to do a logarithmic fit, that is essentially doing an exponential fit with x as the independent variable and y as the dependent variable. Anyways, now let's see how the least square method works. So I want to minimize. I hope you understand the summation sign. Are you familiar with the summation
Yes,
sign?
yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
And you are trying to fit something like this. Now, yi and xy are the experimental data points. Those for you are actually the constants. I mean, you might think in a reverse way that M and C are the constants, okay, arbitrary constants as you call them. But in this problem, when you are trying to fit M and C, those are the variables. Whereas your experimental data points, those are constants. So be clear with which one of these are constants and which one of these are variables. M and C should be adjusted. Their values needs to be calculated. That's when you have your best fit. Okay. So those are variables. Whereas the data that you are working with, you don't have any control over that. That's the data. So those are constants. Now, to have the best fit, we need to do optimization. So basically, we would set the partial derivatives because there are two variables involved, two independent variables involved. So you would set the partial derivatives to 0.
Okay, sir.
Okay.
Okay, sir.
Okay. So now one good thing about derivatives is that is a linear operation. Okay. And every linear operation basically finds the summation sign transparent. And money, you get to do this.
Oh, means we can take the partial derivative inside the sigma.
Yes. So, or you can think of this, right? Let's say something is UVW, like this. Then dy dx is u prime plus v prime plus w prime. Prime being derivatives with respect to x.
Yes, sir. Yes, sir.
So differentiation and integration, these are linear operations. So they are like they go inside that summation sign. So basically, you are taking the derivative of individual terms. Now, what happens when I take the derivative of one of these terms, the ith term? This is what happens twice: yi minus m of xi minus c, and then I'm taking derivative with respect to c, right? So what do I get? A negative sign? Doesn't matter because in the end I'm comparing this to 0. Now, what am I getting here? So what does that? So first of all, I'll cancel the 2. The 2, the minus 1, they do not matter. So I have this thing. Summation over I equal 1 to m yi minus m of xi minus c. Okay. So this can be written as summation over yi, the first term, then m times summation over xi, and the last term is you can think of c as c times 1. Okay, and that will help. So basically this becomes c times summation over I equals 1 to m 1. Basically you are adding c n times up. So in the end you have this n times y bar minus m times x bar, where bars are basically the mean values. Okay, and by definition
Okay,
these
sir.
are so m times n times x bar minus n times c equals 0, or in other words mx bar plus nc minus, sorry, not nc but c minus y bar equals 0. And let's call that equation 1. And there is a reason why I wrote it something like this. I didn't write y bar equals mx bar plus c. No. Because you'll have to understand again, this x bar and y bar you can get from your existing xy data, right?
Yes, sir.
X1. So these are constants. What are not are m and c that you are supposed to calculate. So I'm writing a linear equation. Okay, that in the end would with another linear equation that is about to come, as you need to solve simultaneously to get the values of m and c. So now let's take the derivative with respect to m. There is a reason I chose to do this, the one with the c first, because that turns out to be simpler. Now again, the first part is very similar.
স্যার একটা কোশ্চেন আছে।
হ্যাঁ বলো।
হ্যাঁ বলছি ওই সেকেন্ড লাইন থেকে থার্ড লাইনে কিভাবে আসছেন, মানে ওই সামেশন অফ ওয়াই প্লাস মাইনাস এম এক্স আই মাইনাস সি ইন্টু ওয়ান, না তার আগে, হ্যাঁ হ্যাঁ ওই কোয়েশ্চেন
এই লাইনটা থেকে এখানে
এক্স্যাক্টলি
মানে দেখো এখানে কি ছিল, এই ব্র্যাকেটের মধ্যে পুরো জিনিসটা সাম। ওকে, and that is you are supposed to repeat this, take the terms for every I and add them up. Okay, but what I instead chose to do is if I write this up, so this is y1 minus m times x1 minus c, okay, plus y2 minus mx2 minus c, plus yn minus mxn minus c. Okay, this is the meaning of this summation right here.
হ্যাঁ ওটা বুঝতে পেরেছি বাট কথাটা হলো মানে ওই যেটা আপনি এক্সপ্রেস করলেন ওটা আগের লাইন থেকে, মানে 2 ইন্টু ওয়াই আই মাইনাস এম এক্স, হ্যাঁ এক্স্যাক্টলি এখানে, হ্যাঁ।
Okay, so I can bring out the minus 2.
I mean that is equals to 0.
That equals 0, right? So
ও আচ্ছা
No, এমনি তো ক্যান্সেল চলে যাচ্ছে।
এবার
This is why the last line is coming.
so minus 2 again over here. No, minus 2, but এটা কি বুঝতে পারছো এখানে একটা xi হবে when I'm taking derivative with respect to m.
Yes sir, chain rule. So I get minus m instead of minus 1. Unlike c, I get minus m. Okay, minus xi, sorry, not minus m, minus xi. And xi cannot come to the left of summation sign because it's a part of you are taking derivative of individual terms. It is multiplied, this xi is multiplied to only this term yi minus mxi minus c, and xi are not same, so it cannot come out of the summation sign. Minus 2 can, but xi cannot. So in the end you have this equation, summation of xi yi minus m times summation of xi squared minus c times n times x bar equals 0.
yes.
Okay, so this is your second equation. And once you solve these two equations, okay, you have the values of m and c. Okay, and then so basically you solve them just the way you solve any linear equation, right? So so you can substitute for this. So for example, I can write c equals y bar minus mx bar. Okay, so just substitute it over here and then you have the value of m. Okay, now what I need you to do is write at this point. এই পার্টটা বোঝা গেছে তো পুরোটা?
হ্যাঁ স্যার এখন ক্লিয়ার আছে।
ঠিক আছে, আচ্ছা।
Yes sir, yes sir.
So what I need you to do is, on a piece of paper, okay, এটার জন্য এটাকে প্রোগ্রামে লিখতে গেলে, if you are supposed to write it in a C program, you don't have to write the actual program. Okay, what you can do is you can write the algorithm for this one. Can you write the algorithm for this one? Okay, and right at this point what I'm doing is I'm creating an assignment. Okay, so so you have time till 10:20. Okay, so 10:20 তার মধ্যে তোমরা এটা কমপ্লিট করে আমাকে তোমাদের এই মুহূর্তে কারো ইন্টারনেটের ইস্যু নেই তো?
স্যার মানে ওরকম ভাবে ব্লগস বানিয়ে লিখতে হবে না, স্টার্ট করে যেরকম ভাবে আমরা বানাতাম অ্যালগরিদমস গুলো সেইভাবে তো?
হ্যাঁ হ্যাঁ, অ্যালগরিদম। তো যদি তোমাদের কারো ইন্টারনেটের ইস্যু থাকে জানাও, যাদের নেই আমি ধরে নিচ্ছি এই মুহূর্তে
ইস্যু নেই, তবে স্যার
বলো।
আপাতত স্যার না স্যার, যদি এবারে আপাতত ইস্যু নেই।
ওকে, তো আমি কি করছি, আমি একটা অ্যাসাইনমেন্ট ক্রিয়েট করছি ক্লাসরুমে। ঠিক আছে, তোমরা 15 মিনিট টাইম আছে, তার মধ্যে ওটাকে কমপ্লিট করো, করে সেখানে আপলোড করে দাও। ওকে, একটা ছবি তুলবে, একটা পেপারের মধ্যে লিখবে অ্যালগরিদমটা, ছবি তুলবে, তুলে আপলোড করে দেবে।
স্যার হ্যালো, স্যার, আমার কি নেটের প্রবলেম হচ্ছে?
না 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 না, শুনতে পাচ্ছি আমরা।
ও, আমি না বুঝতে পারছি না যে ঠিক কি
হ্যাঁ,
করতে হবে, মানে মানে
হ্যাঁ মানে
কোনো একটা
অনেকদিন ধরে করা নেই তো, তাই জন্য একটু মানে আমরা জাস্ট
না,
মানে আমি জানি
আমি
অ্যালগরিদমের কোডটা কিরকম।
অ্যালগোরিদমটা লিখতে হবে।
এটা করতে হবে।
আরে অ্যালগরিদম লিখতে হবে,
হ্যাঁ।
স্যার সেটা বললো, বাট কি করতে হবে মানে আমি তো সেই বুঝতে পারছি না যে মানে অ্যাসাইনমেন্টও তো
আচ্ছা,
দেখেছি।
কথাটা শোনো, বলছি যে এই যে ফাংশন লিনিয়ার এটা দিচ্ছে, এটার অ্যালগরিদম এটা লিখতে হবে, ফ্লোচার্টটা।
হ্যাঁ, ফ্লো চার্টটা লিখতে হবে, কিন্তু ফ্লো চার্টে কয়েকটা জিনিস তো ভুলে গেছি, ব্যাপারটা হচ্ছে এইটা।
ও আচ্ছা, ঠিক আছে, ঠিক আছে।
স্যারকে বল না যে অন্তত আছে ক্লাসের পর 1 ঘন্টা সময় দিন, তার মধ্যে করে দেবো, এরকম ভাবে
ঠিক আছে।
স্যারকে।
আচ্ছা, এটাকে ফ্লোচার্ট তৈরি করতে হবে?
হ্যাঁ, খানিকটা ওরকমই।
অ্যালগোরিদম।
হুম।
আমাকে একটু বলবি
ওটাই
কিভাবে
ওটাই ওটাই ওটাই।
মানে স্যার যে লাস্ট ইকুয়েশনটা দিলেন ওটার উপর না দুটো ইকুয়েশন মিলিয়ে?
লাস্টে বলে দিন।
আচ্ছা, এখানে কেউ কি তোরা বুঝতে পেরেছিস কিভাবে তোর করবি অ্যাসাইনমেন্টটা?
চেষ্টা করছি।
বাট ক্লিয়ারলি যদি কেউ বুঝে থাকিস তাহলে আমাকে বল।
ওটার ফ্লোচার্টটা ডিজাইন করতে হবে। হুম।
হ্যাঁ, একটু ভালো করে বল, শুনতে পাচ্ছি না।
আমরা যে লাস্ট ইকুয়েশন দিয়েছে সি মাইনাস হুম, ওটার ওটার ফ্লোচার্টটা ডিজাইন ইকুয়েশন করে।
আমার মনে হয় পুরো ইকুয়েশন অব্দি নিয়ে আনতে হবে, তো পুরো ফ্লো চার্টে তোরা দেখাতে হবে কি করে ইকুয়েশনটা আসলো।
না, ইকুয়েশন, ইকুয়েশনটা তো
দুটো গিভেন ইকুয়েশন আছে, সেখান থেকে তোকে সলভ করে এমআরসি ধরাটা বার করতে হবে।
গুলো বার করতে হবে, তোকে এক্স বার আর ওয়াই বার গুলো ডেটা থাকবে, এরকম ব্যাপার।
फ्लो चार्ट बनाना है या स्टेप्स लिखने हैं?
फ्लोचार्ट बनाना है सर।
আগে যে সি এর ফ্লোচার্টটা করেছিলাম ওই রকম তো?
হুম।
হুম হুম, অনেকটা পুরো।
হয়ে গেছে লেখা?
স্যার
ইয়েস।
স্যার বলছিলাম যে এই যে আপনি এখন একটা লাইভ একটা অ্যাসাইনমেন্ট দিলেন, বলছিলাম যে কি আমরা না অতটা প্রফিশিয়েন্ট নই মানে ফ্লো চার্টস নিয়ে ওয়ার্ক, কেন কি আমরা নিজের আগের সেমিস্টারে যেটা করেছিলাম মাত্র একটা অ্যাসাইনমেন্ট করেছিলাম, তাই জন্য অত বেশি গ্রেপটা নেই স্যার এখানে। তো আপনি যদি আমরা মানে সাবমিট, জানি না আমার কত বন্ধুরা করেছে কিনা, কিন্তু আপনি যদি একবার একটুখানি বলে দেন এরপরে তাহলে একটু সাহায্য হয় স্যার, তাহলে কনসেপ্টটা বুঝতে পারবো ভালো করে।
তুমি যেটা সাবমিট করেছো দেখছি সেটা কিন্তু ফ্লো চার্ট, আমি কিন্তু ফ্লো চার্ট বলিনি। এনিওয়েজ, বাট তুমি যেরকম ফ্লো চার্ট লিখেছো দ্যাটস গুড এনাফ। তো যদি আমাকে অ্যালগোরিদম লিখতে হয় আমি হয়তো এইভাবে লিখবো। তো প্রথম স্টেজটা হচ্ছে যে আই উড আস্ক দ্য ইউজার ফর number of data points.
ওকে স্যার।
ওকে, মানে আমাকে যদি সিউডো কোড লিখতে হয়, সিউডো কোড হচ্ছে বেসিক্যালি দেখতে প্রোগ্রামিং ল্যাঙ্গুয়েজের মতো, কিন্তু আসলে কোনো প্রোগ্রামিং ল্যাঙ্গুয়েজ নয়। তো দ্যাট উড বি লাইক রিড এন। ওকে,
Yes.
and then you can initiate xn yn, right? তাই তো?
Yes, yes.
ধরো
এইটাই
আমি যখন
যাচ্ছিলাম।
সি প্রোগ্রামিং এ করব, আমি যখন সি প্রোগ্রামিং এ করেছি তখন আমি হয়তো এরম ভাবে করেছি, আমার জন্য আমি লিখেছি হয়তো ইন্টিজার n, then real I have done like 20, say 20. Okay, then when I ask for enter number of data points, n, then maybe colon, and then new line. When I did that, I also wrote, either I wrote this maximum allowed 20, okay, and then I would read n Then I would read n, and I have then 2-line programs. If n n, then I would print again accepted value n equals percent t slash n, then the value of n. So I would first ask for the number of points, and I'll also mention what is the maximum value allowed. I'll read it, okay, and then check whether it falls under the limits. If it is less than 1, there is no way I can fit a straight line, because there are infinite number of straight lines possible, right? So it has to be at least 2. So I took 2, and in the end I would print what is the value that I have chosen as the accepted value. I'm not saying that's what you are supposed to do for each and every data points, but maybe the starting value is fine. Okay, and after that I'll only work with the first in values, first in columns of x and y. That's the idea. Okay, if n is 5, then I'll only work with the first 5 columns of x, or first 5 rows or first 5 columns of x or y. Okay, Achha. Now this is actually how your this is actually the part of your C programming would look like, but that you are probably familiar with. If I ask you to write, you are allowed to write either the algorithm, I mean, when I ask you to submit live assignment, you can either write the algorithm or the pseudocode. Okay, so I initiated x and y, and then read x1 to xn, then read y1 to yn. Okay, then I can get the certain calculations. Okay, so for example, I can define one of the constants as C0, which is sum of xi divided by n, and I can then define C1 as sum of all the yi's and then divided by n. Okay, and then what we can, so what these two are, pseudocode or algorithm, is basically a rough planning without bothering about the syntax of the programming or language, simply doing a planning for how your program would look like. Okay? So I'm not using any particular syntax. Okay, then you would calculate the 6 coefficients that are associated with the 2 equations of the straight line. So in the end we get 2 equations of the straight line, and once you do so, you have this 6 coefficients. Okay, and if you do some hand calculation, symbolic hand calculation, then you would have certain expressions for m, and then you can substitute that expression to C as y bar minus m times x bar, right? So after that, you write this equation for m, you write the expression for m in terms of C0 to C5, and then the expression for C should be, also you need to initiate C and m, right? Also you need to initiate C0 to C5. So you get, I have not calculated the the expression for m, so I'm not writing it. But for C, you can write it to be C1 minus m times C0.
C not, huh? ঠিক আছে।
Okay, and then you can print m and c. Okay, so that's what the pseudocode would look like. But of course, when you are trying to write it using C, it has its own set of syntaxes. But in the class, it may not be a good advice to right away write the C programming, because if it were a offline class, I would go to your terminal and check your program, and if there is a mistake, I could help. Or but since it's not that, it would be very difficult to check the C programming. So what you can do is you can write the program later. So whatever assignment I give you as live in the class, that also falls under the assignment for which you are supposed to submit the program. But this program you can do later. In the class, you can write down the pseudocode. Okay. So
Yes,
the evaluation of the class performance would be based on either the pseudocode or the algorithm. So basically, what would be algorithm? This pseudocode that you see here, if I were to write them in terms of words, okay, then that would be basically your algorithm. Okay.
So,
Yes.
sir, can you explain that part of C0 and C1 is clear, but then C2, C3, C4, C5. I mean, what was that?
Okay, I forgot what expressions I wrote for the two linear equations, right? So you can imagine these are the coefficients. You see, I have two linear equations involving m and c, right? So basically, each equation of m and c would probably require 6 of such coefficients. Okay. It may be 6 or it may be even 4 actually. If you do some manipulation, that would be 4. Okay, but I'm just assuming there are 6 coefficients. Okay, for each equation, there is 3, so a total of 6 coefficients. So you can, in the end, you can have one expression of m in terms of all those coefficients, right?
Yes.
Okay, so I mean, I'll have to otherwise go back to the equations that I wrote for. Okay, let's see. So there was the first one was this one, right? This equation, which was okay. So maybe not 6 coefficients. Okay, here you have 2 coefficients, C0 and C1, C1 and C0. The other one was summation of
Xi
xy minus m times summation of
xi square.
xi square minus c and x
yeah,
bar.
summation of xi squared c times nx bar.
And x bar, yes, sir, equals to 0.
So yeah, so I can call this one C2, C3, and this right here as C4. So maybe not 6 coefficients, maybe 5 coefficients. And actually, what you can do is you can divide everything with C3. Then you have only 4 coefficients, and that's how many coefficients you should have for 2 linear equations, right? So maybe not 6 coefficients, maybe 4 coefficients. Okay. So whatever the case may be, you are actually supposed to write those only. Okay. So is it clear how to write the pseudocode, or so if I were to so input number of data points? Okay.
Sir, in supposed case, we have to do the subtraction. Then we would use the symbol as subtract xi and something like that, because you have used sum in case of subtract and multiplication. Could you tell us on that one?
No. If I have to do y equal mx plus c, I'll write y equal mx plus c. See, the sum is summation of yes. So I mean, mathematically we can write summation over I xi, right? But there is no since the programming languages are in ASCII format, right? So in ASCII format you don't get to write summation. I mean, of course, there is a summation sign, but there is no programming language which interprets summation sign as a summation. So the typical function for that should be sum. I mean, it is quite universal. You can go to MS Excel, okay, select 10 rows of a given column, okay,
Yes,
and
equals to sum, that formula.
and if you do a sum, if you use this command, basically gives the sum of this.
Yes,
Okay,
yes.
or you can go to MATLAB or Fortran or C. Everywhere the sum has this universal application. Okay, so sum would basically sum. Okay, but one thing, I don't know whether you can directly sum one vector in C. So what I would do is, if I were to get the summation in C programming, I would set s equals 0, okay, and then this is how the command goes for
Yes, yes. We will
I
be using
equals,
loop.
yes, I less than n, I plus plus. I would do this. I would not go for a second line. In the same line, I would write s equals s plus xi. This is the correct syntax for C programming.
Yes, yes.
Okay. I don't know if there is a direct command sum for a vector, but some programming languages do offer this sum. For example, Fortran offers, okay. MATLAB offers. So I believe even Python offers. So for those programming languages, you can. I mean, it's a pseudocode. It's not supposed to be in the syntax of any program. Okay. So that's why I wrote sum. If you're trying to do a simple mathematical operation, just put the symbols for them.
Yes, yes.
Let's say there is a multiplication. What you can do is you can write it like m, then put an asterisk, then x plus c. Because let's say if we are trying to do that in any programming language, this is the universal representation of multiplication with
Yes.
with an asterisk. Okay.
Yes, sir.
Okay. Okay, so I'm leaving this up to you. So far, only 3 people have turned in. It's okay. So let's move on to the next topic. Correlation coefficient. So correlation coefficient is so we were earlier talking about fitting a straight line through a set of data points, and in that we also mentioned that maybe a straight line is not the correct fit for the given data point, or maybe straight line is not the correct trend. So how do you evaluate a trend? I mean, if the xy data point is kind of like this, then obviously, in some sense, a straight line is not a very inaccurate trend for this data point. Whereas, if it is something like this, then a straight line is essentially not are correct trend. Okay, or for that matter, maybe there is almost no correlation between these two data points. Okay, but the correlation coefficient that we are about to discuss is only related to linear correlation. Okay, later on we would see if there is a nonlinear correlation. Okay, can that also be evaluated? Now let's say you have a data point, you have a set of data points which does this. If you try to fit a line, it would probably give you something like this. Okay, and the correlation coefficient that we are about to discuss, which basically is a scalar which measures how much the two set of data, the x and y data, are correlated. Okay, so that correlation coefficient is meant for predicting linear correlation, and whether it is a non-correlated data like this one or non-linearly correlated data like this one, it yields a very poor value. Whereas for this one, where the relationship is more or less linear, the trend is quite evident from the plot itself, this correlation coefficient that we are about to discuss gives a pretty high value. Now, what are the high values? The high values are plus and minus 1. Okay, and the low value is 0, the lowest value, and these are the highest value. Now the values are typically anywhere between -1 to +1. Now in what situation is it -1? It is -1 when the data set of data points are exactly falling on a line, and the trend is kind of like this. Basically, m is negative. That's one. And if the data points are not exactly falling on a straight line, slightly scattered, so in that case the correlation coefficient would still be negative, but slightly the absolute value would be slightly smaller than -1. Now this is how we define this correlation coefficient, which is this correlation coefficient is called Pearson's R. Okay. Now, are you familiar with any of these symbols? Do you know what these coefficients are? Quantities are?
No, sir.
Sir, we had it in our class 12, but sir, it is the faded memory, sir.
Faded memory. Okay. I also study statistics in 12th standard. And that is the only time I studied it properly. Anyways, so you know what these quantities are. These are called standard deviations. Okay. It basically measures how much dispersed a set of values are with respect to their mean values. For example, if you have x values from A to B, okay, the mean value is somewhere in the middle of A and B, okay, if not exactly A plus B by 2, somewhere. And the standard deviation is kind of an average measure of how far each of the other data points are. The average measure of how much is the deviation from the mean value of the different x values. And this is how the standard deviation is defined. Now, On the numerator, you have covariance of xy. You discuss that in a minute, but this sigma x and sigma y are the standard deviations of x and y. Okay, so sigma x right here is called a standard deviation of x. It is basically square root of the variance of x. The standard deviation, also known as RMSD, not sigma squared, but sigma is called RMSD, root mean squared deviation. Now, what is var of x? It is summation of I equal 1 to n, 1 by n because it is mean, deviation from the mean value, hence the squared deviation right here, squared deviation mean. So variance is the mean squared deviation, and the root of that is the standard deviation. Root means squared deviation. Okay, and here you are about to see something very similar to what you have seen in parallel axis theorem. So now, if I expand this, so I have the following expression. Sorry, I going from 1 to n. Xi squared minus twice xi x bar minus x bar squared. Now x bar is a constant, that is the average value of all the xi's. So you have mean of the squared values, then twice x bar comes out of the summation 1 by n summation xi. Now, can you tell me what this quantity is? 1 by n summation x bar, summation xi.
This is basically the averaging.
That is the x bar.
X bar, yes, I mean, mean.
1 by n times x bar squared. Because it is being summed n times, so n times x bar squared. So you can simply cancel the two n's. Now you see here it is twice x bar times x bar, and this is x bar squared. If you recall, in parallel axis theorem, you encountered a very similar expression where, when you were deriving parallel axis theorem, you are taking the distance of different points with respect to the centroid, and eventually
Yes,
the average value should be 0. Okay, it's slightly different, but also slightly similar. So in the end, you have the following expression. You take the mean of this thing squared, sum of the squared values minus x bar squared. That is the variance. And you basically take the square root of that to get the standard deviation. Okay. And this is how the covariance is defined. So one thing, let us define x prime as x plus a0. Then standard deviation of x prime is standard deviation of x plus a0. Now this also tells you the average value of x prime is the average value of x plus a0. So x minus x bar, xi minus x bar, or x bar, sorry, x prime I minus x bar prime is xi plus a0 minus x bar minus a0, which tells you this is the standard deviation of x. Okay, so you take a set of values of x and simply add a constant to each of those values. Let's say 5 with each of those. Okay, since the standard deviation is a deviation from the mean value, that doesn't change when you add a constant value to each of the data points. Okay, each of the values of x. এই পার্টটা বোঝা যাচ্ছে তো, যে স্ট্যান্ডার্ড ডেভিয়েশন ডাজন্ট চেঞ্জ when you স্ট্যান্ডার্ড ডেভিয়েশন ডাজন্ট চেঞ্জ when you হ্যাঁ বলছি। ধরা যাক তোমার কাছে এরকম কতগুলো ডেটা ছিল, 1 3 5 7 এরকম, ঠিক আছে, need not be uniformly distributed, দুখানা 7 থাকতে পারে, তিনখানা 3 থাকতে পারে, যা খুশি থাকতে পারে, ঠিক আছে। এবার all you did was shift with a constant, let's say 2, so 3 5 7 9 9 5 5. Since the standard deviation by definition measures the dispersion or deviation from the mean value, average deviation from the mean value, the mean value itself, as you can see, has shifted by the same constant. Air average যদি somewhere around 6.5 হয়, so this thing should be 8.5. I don't know what is the mean of this thing, but I know for sure because I'm adding a single constant value to each of the values, single constant number to each of the values, the shift is same for individual values and the mean. So in the end, মানে আমি যদি ভিজুয়ালাইজ করতে চাই, আমার এই এক্স ভ্যালু ছিল, তার মিনটা এখানে ছিল, ওকে, আর দিস গ্রিন সার্কেল হ্যাজ দ্য রেডিয়াস অফ স্ট্যান্ডার্ড ডেভিয়েশন। ওকে, আমি প্রতিটা ভ্যালুর সঙ্গে 10 অ্যাড করে দিলাম, এখন ভ্যালুগুলো এখানে চলে এলো। Okay, so now I would see that the mean has shifted by that value that I have added to each of the individual values. যদি আমি 10 করে অ্যাড করে থাকি প্রত্যেকটা ভ্যালুর সঙ্গে, তাহলে মিনটা has shifted by 10. Okay, and the deviation from the mean value hasn't changed. এটা কি বুঝতে খুব অসুবিধা হচ্ছে?
স্যার বুঝছি, বাট মানে কোরিলেটটা করতে পারছি না, মানে প্রবলেম হচ্ছে।
এই পার্টটা বোঝা যাচ্ছে যে x bar prime is x prime plus a0, বোঝা যাচ্ছে তো? Then subtract from individual x prime I, subtract its mean value.
মানে স্যার x bar prime equals to x bar plus a0, মানে এখানে যেখানে গ্রাফে যেখানে বললেন যে 10 করে প্লাস করলে তাহলে মিন ভ্যালু গুলো শিফট করে গেল, এই জিনিসটাই তো গ্রাফে এটাই
যেটা বলছি। হ্যাঁ, একই জিনিস বলছি। যদি গ্রাফে বুঝতে অসুবিধা হয়, সিম্বলিক্যালি বল, I have added a same constant value to each of the individual values. Therefore, the mean value also shift by the same amount. যদি সেটাও বুঝতে অসুবিধা হয়, এখানে একটা করে I বসাও, then put a summation. Then you have n times x bar prime. This is n times x bar and this is simply n times a0. Divide everywhere with n, then the mean value also shifts by a0. যদি প্রতিটা ভ্যালু a0 করে shift হয়, so the mean value only shifts by a0.
Yes.
And standard deviation is a measure of deviation from the mean value. So for that I need to subtract x bar prime from xi prime, or x prime I from xi prime. I need to subtract x prime bar. So I'm just writing their expression. So xi prime is xi plus a0, and x prime bar is x bar minus plus a0. So when I do the subtraction, since the mean value and the individual values have shifted by the same amount, okay, the difference, the deviation from the mean value of the individual values, that hasn't changed, because everything has a rigid shift. Okay, so the difference of the individual values from the mean values hasn't changed. তার মানে কি, আমি যখন স্ট্যান্ডার্ড ডেভিয়েশন অফ x প্রাইম ক্যালকুলেট করব, I'll replace this thing with xi prime, x prime I minus x prime bar. But we just discussed that that difference hasn't changed from x to x prime. So that difference still remains xi minus x bar. And that is true for each and every value. Okay. And therefore, in the end, the standard deviation remains the same. এবার বোঝা গেল?
হ্যাঁ স্যার।
সবাই বুঝতে পেরেছো?
হ্যাঁ স্যার।
যদি বোঝা গিয়ে থাকে, দেখো তো এটা বোঝা যায় কিনা। এবার ধরে যাক একটা y রয়েছে, x প্রাইমের বদলে y রয়েছে। That is simply m of x, m times x, not m of x, m times x. Therefore, y bar একইভাবে ভাবো, সামেশন নিয়ে, would be m times x bar. So the standard deviation, which is square root of 1 by n y minus summation over 1 minus y minus y bar whole square, which would be 1 by n summation over mxi minus mx bar squared. In the end, the m comes out 1 by n summation over xi minus x bar whole square, m is dx. এটা বোঝা গেল?
Yes, sir.
ওকে, এবার আমি যদি একটা করে রিজিড শিফট দিই পুরো ডেটা পয়েন্টটাকে, মিন ভ্যালুটা শিফট হয়, স্ট্যান্ডার্ড ডেভিয়েশনটা শিফট হয় না। স্ট্যান্ডার্ড ডেভিয়েশনটা শুধু স্কেল হয়, দিস ইজ দ্য স্কেলিং প্যারামিটার, দিস ইজ দ্য শিফটিং প্যারামিটার। মিন শিফটস অ্যান্ড স্কেলস, স্ট্যান্ডার্ড ডেভিয়েশন অনলি স্কেলস। তাতে করে কি দাঁড়ালো? তাতে করে দাঁড়ালো এটা, if x and y indeed belong to a straight line, or in other words, if y is indeed an exact linear function of x, therefore sigma y is sometimes some form of m times sigma x. And let's see what happens to covariance of xy. which is 1 by n summation over I xi minus x bar yi minus y bar. If indeed y is a linear function of x, such as y equals mx plus c, therefore y bar is also m times x bar plus c. So this thing could be written xi minus x bar mxi plus c minus mx bar minus c. So in the end, this equals m divided by n summation over I equals 1 to n xi minus x bar whole squared. Or in other words, it is m times var x, which is sigma x squared. So in the end, R is m times sigma x squared, sigma x, m times sigma x equal 1. Acha, one thing. This is m absolute, because this is coming out of a square root. You see, it is coming from standard deviation, right? So it is coming in the form of a square root. It is coming as the square root of m squared. So m can be both positive or negative. So this is how we are supposed to write this. It's the absolute value of m times sigma x. So this is actually not 1, this is actually m divided by m absolute, or in other words, this is called the sine of m. তাতে করে কি দাঁড়াচ্ছে, যে যদি exactly y of x follows this trend, যদি ডেটা পয়েন্টগুলো এরকম হয় অথবা এরকম হয়, I'm going to get the extreme values of R. And in a way, it's a measurement of linear correlation between y and x. So if indeed y and x belong to a straight line, this R would have an absolute value of 1. And any smaller value is only a deviation from the linear correlation. Is it clear? এই অবধি বোঝা গেল?
Yes, sir.
Okay. আমরা আরো কিছুটা অ্যাডভান্স টপিক করব। সেটা করার আগে একটা জিনিস বলি, এই যে এক্ষুনি যে অ্যাসাইনমেন্টটা দিলাম মাত্র 3 জন সাবমিট করেছে, তো বাকিদের বলছি লেটস টেক আ ব্রেক অফ 5 মিনিটস এবং এই টাইমের মধ্যে তোমরা আপলোড করে নাও, ঠিক আছে? সো উইড come back to this discussion within 5 minutes. তোমাদের এটা 4 পিরিয়ডের ক্লাস তো?
11 থেকে 2 অবধি হওয়ার কথা, যদি থার্সডেতে হতো।
3 আওয়ার, কিন্তু আমি যে সিলেবাসটা পেয়েছি there everything is mentioned in terms of 4 hours. It's okay, so we'll have to be you know, have to have that idea that it is of 3 hours. Each class is of 3 hours. It's okay. So আমার আর 1 ঘন্টারই discussion বাকি আছে. Okay, so you I hope you understand by now. So your assignment would be to also submit the program for this one, C program, okay, for this one. But right now your class assignment is to submit either the pseudocode or the algorithm for the the linear fit. Okay, তো যারা করনি এখনো পর্যন্ত তারা লেটস কাম ব্যাক এট 11:10. সো 11:10 এর মধ্যে তারা আপলোড করে দাও.
স্যার ক্লাসরুমে সি প্রোগ্রামিং এর মানে কোশ্চেনের টপিকটা একটুখানি আরেকবার একটুখানি ডিফাইন করে দেবেন.
Okay, see, the problem statement is you are supposed to take data points less than 20. You are supposed to ask the user to provide you with XY data points. Okay, and you can program it in any way. It can be read from a set of data points. Okay, it could be generated by a function. Okay, I mean it could be read from a file. It could be generated by a function maybe, and or the user could I mean, I'm not asking you to provide all the 3 options. It can have one of the 3 options. Okay, or the user could be directly putting them on the terminal. That is fine. Okay, and in the end your job is to check whether they are providing less than 20 data points, less than or equal to 20 data points, and then you are supposed to fit the straight line accordingly. Okay, and answer with your coefficients. বুঝে গেল প্রবলেম স্টেটমেন্ট?
আচ্ছা স্যার, এই ভিডিওটা আমরা কি করে পাবো, মানে রেকর্ডেড ক্লাসটা? ওটা কি আপনি?
আমি ইউটিউবে আপলোড করে দেবো, ঠিক আছে?
ওকে স্যার।
আর আমার ইউটিউব চ্যানেলের লিঙ্কটাও আমি শেয়ার করে দেবো.
হ্যাঁ স্যার, অসুবিধা নেই।
Hello, sir. Hello, sir.
কি অডিবল আছে, শোনা যাচ্ছে?
বলো।
হ্যাঁ স্যার বলছি আমি সাবমিট করেছি আর এই মুহূর্তে অ্যাকচুয়ালি আমার এইচওডি স্যার একটা কল আসছে তো আমাকে একটু লিভ করতে হবে স্যার।
ঠিক আছে, যাও।
ওকে স্যার, থ্যাংক ইউ সো মাচ স্যার। স্যার রেকর্ডিংটা একটু আপলোড করে দেবেন।
Okay. Now, because we have seen how to fit a straight line, so we can use the same technique to fit a power law curve or exponential or a logarithmic fit using a very similar technique. Now, what happens when we try to fit polynomials? Let's say to a set of data points, I want to fit something like this. Okay. So how do I do that? Now, say n equals m, okay, or rather n equals m plus 1. In that situation, what you can do is, so there are m plus 1 different points, different, they have to be different, okay. So in that case, so if there are this many points, so this is what we can do. Look at this sum, c0 uh, plus C1x. So basically, I can write individual terms to be summation over Cj. J goes from 0 to m, x to the power x yi is xi to the power j. Okay. Now this can be thought of in two different ways. One is there is a C0, C1 up to Cm, like a row vector multiplying. So basically, I'm doing a dot product of two vectors. So the first vector is supposed to be written as a row, and the second vector is supposed to be written as a column. And then xi to the power 0, xi to the power 1, up to xi to the power m. You can either think of this summation as this dot product, okay, or you can think of this to be this dot product. Multiplying C0, C1 up to Cn. Now, when you do write this expression like this, you get to write something like this matrix and vector format, where this quantity y vector is basically y1, y2 up to yn, and this c vector is a coefficient vector which is c0, c1 up to cm, and in the middle lies this vector. So you see, the reason I wrote it something like this, because I want to solve a linear set of equations, a set of linear equations. Okay. So these coefficients are the unknowns for me. If you really think about it, when I'm trying to fit the polynomial, I can easily calculate xi to the power j for any I from 1 to n, and for any j in 0 to m. I can calculate, because this data is available to me, values of xi's are available to me, and I can simply raise one of those values to a given power. So I can calculate this entire coefficient matrix. Let's call it A. So this would look something like this. The first column is everything to the power 0. So it is x1 to the power 0, x2 to the power 0, xn to the power 0. Then comes x1 to the power 1, x1 to the power 2, up to x2 to the power 1 up to xn to the power 1, and this progresses. In the end, it is x1 to the power m, x2 to the power m, and in the end, xn to the power m. Now, what are xi to the power 0? To the power 0 basically means these are all ones, 1, 1, up to the nth term, and to the power 1 is basically that quantity itself. So it's like x1, x2 up to xn. Now size of this matrix is n cross n plus 1. And if n is indeed n plus 1, then it's a square matrix. Then you have number of equations equal number of coefficients or number of unknowns. Okay, and then you can solve this system of equations, okay, to get the values of the coefficients. Okay, but let's say you have data points involving, you have a data set involving 100 data points, 100 set of values of x and y. Okay, say n equals 100. Does that mean you are supposed to fit a polynomial of m equals 99? Because a trend could very well be represented, trend might very well be represented by a cubic or a quadratic curve, or at best a fourth order or fifth order polynomial. Now, how do you fit a fifth order polynomial with 100 data points? এই অবধি কি বোঝা যাচ্ছে কি বলতে চাইছি? কিছু বুঝতে অসুবিধে?
না স্যার, আমার ম্যাট্রিক্সটা বুঝতে পেরেছি।
হ্যাঁ,
Yes, sir. No, sir.
Yes, sir, ম্যাট্রিক্সটা বুঝতে পেরেছি।
ঠিক আছে।
okay. Okay, so hopefully you understand this. Now, we are here being given a job of fitting a polynomial. That doesn't mean we don't get to have errors. When you fit a polynomial of n minus 1, m equals n minus 1, to a data set with n data points, you basically get an exact fit. The point is that your fitted polynomial will pass through each and every point. Something like this.
Yes, sir. But if we increase the number of n, then the accuracy will be much higher.
What do you increase accuracy of? If you increase m, the accuracy would be higher.
If n. So, sir, so is there any fixed number that we have to choose, like 100 or 50?
Okay. I am not sure whether you are getting the point. You don't have any control over n. N is what is experimental data that is there. That is just there. Okay. All you have control over is the order of the polynomial. Okay. And and that doesn't mean that if you have 100 data points, you get to take m equals 99. That is insane. That is what this red line over here represents. Okay, I should draw it more clearly. It's not quite visible. So imagine this is y2x data that you have. And one would argue that the behavior is parabolic kind of. But instead, let's say there are 25 points and you chose to go with a 24th order polynomial. First of all, that would be, the computational cost is extensive to effectively invert a 24 by 24 matrix. Of course, you don't really invert a matrix. You use Gauss elimination or other methods that you will be discussing in the future class. But the question is that whatever method you choose to solve a set of linear equations, okay, first of all, solving a square matrix would be an extremely difficult process. Okay. Now, apart from the difficulty, think about this. This gives you an exact solution. When n equals m plus 1, number of equation is number of coefficients. So you get the coefficients. When you take m equals n minus 1, you get coefficients which allows you to fit the polynomial perfectly. Now there is a big issue with perfection. This is how the polynomial looks like. You probably desire a polynomial that probably looks like this. And a parabola, at best a cubic parabola, might have done the job. Instead, you get something called overfitting. Okay, and you must have heard about this term overfitting, because your generation is so much into artificial neural network and data processing. So somewhere or the other, you must have heard about this term overfitting. And this is what the overfitting would look like. This passes through each and every point that you presented your numerical method with. Are you really willing to fit a polynomial that looks like this? That's scientifically, worthless. That has no scientific significance. Because you have to understand that the experimental data or raw data or data from the natural sources, they are often presented with noise. And if you treat noise like it's a valid data, you end up having a polynomial like this. And this is called overfitting. And with the overfitting, you get inaccurate fitting. Okay. Now, that means there are two things. One is, with n data point, you cannot fit a polynomial of order greater than n minus 1. That is for sure. Because in that case, the number of coefficients would be more than number of equations. Okay. If you have m greater than n minus 1, then your number of coefficients would be more than number of equations, and there would be no clear solution. There would be infinite number of solutions possible. That is one thing. The other thing is, you can choose m to be smaller than n minus 1. And that's what actually we are looking for. We are trying to go for m no more than, let's say, 4 or 5 in this situation. In this current example, you are probably not willing to go beyond a 4th or a 5th order polynomial. Okay. So even if you open an Excel sheet in MS Office, get a set of data points, let's say 20x and 20y values, plot a scatter just like this one, okay, and then try to fit a trend. If you try to fit a trend through it, and if you go for polynomial trends, Excel only allows you m less than equal 6. Okay. But question remains, how do you do that fit? How do you do a fit with m less than n minus 1? Actually, way more less than n minus 1. And that's where comes something called a pseudo inverse. And brace yourself, because when we go into the mathematics of that, it's going to be, much more difficult than what you have encountered with linear algebra ever before. এই পার্টের চ্যালেঞ্জটা কি বোঝা যাচ্ছে? That I have been presented with 100 data points, but I'm not allowed to fit a polynomial of order 99. The reason I'm not allowed is because that is scientifically, bears no significance. It doesn't give you any trend at all. You just joined some of the points with a highly nonlinear curve that doesn't make any sense of the data. So let's say if you want to see whether a quadratic or a cubic fit or a fourth order fit gives you an accurate an approximate representation of the data. To do that, you should be in a position to solve for, let's say, 3 or 4 variables given, let's say, 100 equations. Okay. Let's say the maximum order of polynomial that you are allowed is 6, so you can at most incorporate 7 coefficients. And here lies the aspect of the numerical method. The numerical method should always be associated with errors, and there should always be means to minimize the errors. You are not actually being asked, for example, when you fitted a line, you didn't fit a line through only 2 points. There could have been 20 or 100 points, but you were still fitting a line, which is a polynomial of order 2. And you could do that fit, right? So therefore, you should be in a position to do that type of a fit with higher order polynomials as well. Okay. So here we would be discussing about something called pseudo inverse that would enable us to get the best fit coefficients. Listen to this part very carefully. To get the best fit coefficients for a polynomial whose order is a lot lower, than the number of data sets. Okay. So here it goes. So I can represent this matrix vector form okay. I'm putting C hat. Basically, C hat means this coefficient vector. Y hat is this. And you already know what A is. So A is this matrix. So now look at this. What we will do next is we will multiply A transpose with A. We will multiply A transpose with either side. Now A was, so this one is m plus 1 cross 1. This one is n cross 1, and this one is n cross m plus 1. Now A transpose is has a size of m plus 1 cross n. So A transpose A has a size m plus 1 cross m plus 1. This one has a size of n plus 1 cross 1. And this product has a size of n plus 1 cross 1. Okay. And then solve this system of equations. Now, had A been a square matrix, inverse of this quantity, see, every time you invert a product matrix, just like transpose, the order just changes. So this thing becomes A inverse, A transpose inverse. And if you multiply this quantity, had A been a square matrix, so that would be A inverse, A transpose inverse, A transpose y hat. So basically A inverse y hat. Okay. So এটা খানিকটা ঘুরিয়ে নাক দেখানোর মতো। So you didn't have a square matrix to start with. You had a rectangle, and you instead chose to do something called pseudo inverse. That means when A is not a square matrix, then A transpose A inverse times A transpose is A inverse pseudo when n is not equals n plus 1. If A was a square matrix, that would be an exact inverse. But when it is not, then it's a pseudo inverse. So, of course, in linear algebra, inversion of a matrix is a extremely numerically costly operation, and no one exactly inverts a matrix. But solving a set of equation, okay, effectively inverts the matrix and multiplies to y hat, right? To get the values of c hat, the coefficients, you need to effectively do that operation. Hence the name pseudo inversion. And of course, this doesn't give you, once you fit this, you need to realize that you are only limited by the order of m. Okay. You see, the size could be 100 if you choose m equal 4 and n is given as 100. So earlier the size was 100 times 5. But when you did A transpose A, the size was 5 by 5. You are solving a much smaller set of equations. It's much smaller matrix size. Now, now this gives you an how do I say, this is an approximate solution. Okay, this is a best fit solution for mth order polynomial. This is only the best fit solution. It might look like this is an exact fit because you did, A transpose A and you inverted it. And it would have been an exact solution. And the fitted curve would have gone past each and every data point. Had this equality been true, that is n equals m plus 1, if A were a square matrix, if n equals m plus 1, then that would have been true, that the pseudo inverse is actual inverse, and this, the coefficient should be best fitted, and it would give you an exact fit. So all the data points, I mean, we are talking about that fit which we really do not want, wherein it would go past each and every data point. Okay, something like this. The one we do not want. Okay. But once you do a pseudo inverse where m plus 1 is much less than n, then you get the best fit values of these coefficients. Okay. So you get a best fit polynomial that looks quite regular, looks more scientifically significant, okay, and does justice to all the points. Okay. Doesn't exactly pass through any of them, but does justice to all the data points. Hence the best fit mth order polynomial. Now to justify this, how do I know it is the best fit situation? Let's go back to least square error, least squared error. So we are trying to fit Ci's such that when multiplied with that matrix A, again, A is this matrix,
স্যার আগের পেজটা কি মানে মুছে দিয়েছেন একটু?
আগের পেজটা মুছে দিয়েছি। কি বুঝতে পারোনি বলো ওর মধ্যে?
না না ঠিক আছে
আচ্ছা, we are trying to get a fit where we want to get this thing, or rather yi minus aij times cj. Okay, this is the error from the ith source, ith data point. This is the error in the ith data point. Once you would have fitted the coefficients, this would have been the error. Okay, where aij this quantity. Now the square of this quantity is yi minus, there is a summation over j. Now if I do a summation over ei squared, or so-called the error squared, delta squared over I, you see this quantity right here is the ith term of y hat minus a times c hat, the ith component of this vector. So you take y vector, subtract from that. So this a is n times m plus 1. So a times c hat vector. So product would be a vector. So this is m plus 1 cross 1. So product is a vector of n rows, just like this one. So the subtraction is also a vector, okay, like the error vector. So E hat is also n cross 1. And then summation of ei squared is E hat dot E hat. Or in other words, if I were to write E hat as this E1, E2, En like a column vector, so this dot product is the magnitude square of the error, the norm of the error, L2 norm of the error. So that basically is E hat transpose. So the column vector becomes a row vector times the column vector. So this becomes 1 cross n, then 1 n cross 1 gives you a scalar. A scalar is a matrix of size 1 by 1, if you can anticipate that. And then basically this thing means you are taking y hat minus a times c hat transpose of this quantity and multiplying with y hat minus a times c hat. So once you take a transpose, this is what it becomes: y transpose minus c transpose a transpose y transpose a c hat. Expand this one. Okay. And in dot product form, this is how it can be written: y hat dot y hat minus c dot a transpose y hat. Remember, A is a rectangular matrix. It's not symmetric. It cannot be symmetric because it's not squared. Then y dot a c minus c hat dot c transpose a transpose c. So basically a times c, because it can be thought of as a times c hat whole transpose. So this dot c. Again, delta squared equals y dot y minus. Now let me tell you this thing. If you do
a times x. Oh, sorry, I shouldn't be taking a and x. You take t times u. So if you pre-multiply u with t and take a dot product with v, then that is as good as taking u and then taking a dot product t transpose v. Okay. If you
Sir,
don't, sorry.
স্যার বলছিলাম যে আজকে কি এত দূর অবধি রাখা যেতে পারে?
হ্যাঁ স্যার, আজকে একটু এত রেখে দিন।
ব্যাপারটা হয়ে গেছে কি স্যার, আমাদের মধ্যে মেজরিটি লোকজন উই আর পার্ট অফ জেইউ এমএসসি মিন্স মোটর স্পোর্ট ক্লাব, তো আমরা ওটার পরীক্ষা দিচ্ছিলাম স্যার, তো যার জন্য কিনা একটু রাত জেগে কাজ করতে হয়েছে, তো তারপরে আর্লি মর্নিং এ উঠেছিলাম মানে ক্লাস অ্যাটেন্ড করার জন্য। তো স্যার একটুখানি স্যার মানে টায়ার্ড লাগছে স্যার, তো যদি আপনি আজকের জন্য একটু তাড়াতাড়ি শেষ করতে পারেন, মানে এটাই যদি লাস্ট কনসেপ্ট হয় তাহলে স্যার একটু সুবিধা হবে স্যার আমাদের জন্য।
হ্যাঁ, আমি একটা জিনিস বলে নিই, এখন তো ধরো আর 10 মিনিট আছে 12টা বাজতে, আমার এই 10 মিনিটও লাগবে না।
ঠিক আছে, ঠিক আছে।
ওকে, ইটস ফাইন স্যার, ইটস ফাইন, থ্যাংক ইউ।
ওকে, নাও এটা যদি বুঝতে অসুবিধা হয় একটা জিনিস বলি। সো when you pre-multiply a vector with a matrix, you get a vector, right? So a dot product would be summation over I, the ith component of this vector times the ith component of this vector. Now the ith component of a matrix vector product can be written as Tij uj vi, and this could also be written as summation over I summation over j, because the limits on I and j are independent. Let's say I goes from 1 to n1 and j goes from 1 to n2. The limits on I and j are independent of each other. So one can also write uj t transpose ji vi, and then it can be written as summation over j equals 1 to n2 uj, then summation over I equals 1 to n1 t transpose ji vi, which can be written as summation over j going from 1 to n2 uj t transpose v j, or u dot t transpose v. Okay, so I'm just trying to prove this identity, and with the help of this identity I can write this expression I don't actually want to. Okay, also, you know, the dot product is commutative, so the second term can be written as this, and the third term is also this, A transpose y hat dot c, because I can take this A and make it A transpose y, following this identity right here. Okay, so you have a coefficient of 2 coming here, and then in the end, okay, so basically the last term is not negative, it's positive. The last term is so it is AC dot AC. It could be written as A transpose, because AC is another vector, AC dot C. Okay. And this delta square is what you are trying to minimize
this delta squared is what you are trying to minimize with respect to CIs. With respect to CIs, for each and every CI, just like with the linear case, this is only a generalization of the linear fit. So when you take derivative with respect to a given CI, this is the expression that you get. See, the Y values are actually from the experimental data. So these are kind of constants. Okay. This is where C appears and this is where C appears. But you see C appears twice. Okay. I mean, you can take this whole thing and bring it to this side. It will again become A transpose A, because A transpose A is always a symmetric matrix. Irrespective of the nature of A, even if A is a rectangular matrix, this quantity is first should be A transpose and then A transpose transpose, which is A. So this quantity, there is C twice, so you get, once you take derivative with respect to each and every component of C, now I am simply showing a gradient with respect to the C vector. That is what you are supposed to get in the end. You would get minus twice A transpose Y plus twice, okay, it's like there is a C squared involved. So that's why you get to take derivative twice. So twice A hat A transpose A, sorry, A transpose A, C hat. And that should be a zero vector. That means each and every component of that vector should be zero. Each and every row of that vector should be zero. In the end, you have this expression, A transpose A, C hat equals A transpose Y. This is the same expression as the pseudo inverse. Basically, the expression for pseudo inverse you get because of the least square fitting of polynomials. Okay. Now, let's stop here and we'll start discussing on next তোমরা কোন বার ক্লাস করবে, ফ্রাইডে না স্যাটারডে?
স্যার ইট উইল বি বেটার মানে যদি স্যাটারডে যদি না হয় আর কি, বিকজ আমরা উইকেন্ডটা আর কি একটু ফ্রি থাকলে ভালো হয়, বিকজ লাইক টেস্ট এগুলো থাকে তো ওই জন্য আর কি, প্লাস এই ক্লাব ওয়ার্ক যেরকম বললো আর কি। তো লাইক আপনি যদি বলেন যে আপনার অ্যাভেলেবল স্লটস কি আছে, তাহলে আমরা ডিসকাস করে একটা, মানে এখন যেটা ডিসকাস করে আমরা বার করে নিতে পারি, তাহলে সেখান থেকে সেই ডেটে আমরা পার্মানেন্টলি শিফট করে দেবো জিনিসটা।
আচ্ছা, একটা জিনিস শোনো, আমি তোমাদের রেগুলার ক্লাস নিতে পারি, কিন্তু অসুবিধাটা আমার কি হবে জানো, আমি না তাহলে আর কলেজ যেতে পারবো না, বুঝতে পারছো? আমার আর কি মানে সেই দিনটা, হ্যাঁ, তো আপাতত তাহলে ফ্রাইডেই থাক, ঠিক আছে? আর তোমাদের অ্যাসাইনমেন্ট কিন্তু এই পার্টটা রইলো না, মানে পলিনোমিয়াল ফিটিংটা রইলো না, তোমাদের অ্যাসাইনমেন্টটা ওই স্ট্রেট লাইন ফিটিংটাই রইলো, ঠিক আছে? কিন্তু এই পার্টটা তোমাদের একটা সেকেন্ড অ্যাসাইনমেন্ট রইলো, সেটা হচ্ছে এই পার্টে যে থিওরিটা ডিসকাস হলো এটা একটা ফেয়ার কপি করে রিপোর্ট করে, ঠিক আছে, ইউ উইল হ্যাভ টু সাবমিট।
আচ্ছা স্যার, ঠিক আছে।
ওকে স্যার, স্যার একটু রেকর্ডটা তাড়াতাড়ি একটু আপলোড করে দেবেন তাহলে।
দেখো, আমার কাছে যে সময় আসে সবসময় তাড়াতাড়ি আসে না, আমি চেষ্টা করি একদিনের মধ্যে আশা করি হয়ে যাবে, যত তাড়াতাড়ি আসে আমি আপলোড করি।
হ্যাঁ স্যার, হ্যাঁ স্যার, না আপনি আপনার কনভিনিয়েন্ট টাইম অনুযায়ী আপনি এটা দিয়ে দেবেন, আমরা তারপরে দেখে নেব স্যার,
ঠিক আছে? আর এই পেপারের উপর একটা রিপোর্ট জমা দেবে, আর হচ্ছে যে কি বলে আমাদের ওই লিস্ট স্কয়ার ফিটের তোমরা প্রোগ্রাম লিখে সাবমিট করবে। ক্লাসের অ্যাসাইনমেন্ট ছিল হচ্ছে অ্যালগরিদম লেখা, আর হোমওয়ার্ক হচ্ছে প্রোগ্রাম লেখা, প্লাস রাইট এ রিপোর্ট অন দিস ওয়ান।
ওকে স্যার।
ওকে স্যার।
এক্সকিউজ মি স্যার,
হ্যাঁ বলো।
সে বলছি যে আদার স্যার আপনার এটা দিয়ে কিছু অন্য কোনো সোর্স দিয়ে কিছু মানে কোনো বুকস আপনি ফলো করতে বলবেন এরকম কিছু?
আমার মনে হয় তোমাদের ইঞ্জিনিয়ারিং ম্যাথমেটিক্সের বইতে কি নেই এই বিষয়গুলো?
হ্যাঁ আছে তো এগুলো।
এগুলো আছে। আমার ধারণা হয়তো পলিনোমিয়াল ফিটটা নাও থাকতে পারে,
হুম হুম হুম।
সেটা একটু দেখে নিও আছে কিনা। বাট আমি বলবো তোমরা একটু ইন্টারনেটেও দেখো, সবসময় টেক্সট বইতে যে সব মেটেরিয়াল পাবে, কারণ তোমার কাছে একটাই বই আছে, তাতে সব থাকবে নাও হতে পারে। সিউডো ইনভার্সন আর পলিনোমিয়াল ফিট এইটা নিয়ে একটু ইন্টারনেটে দেখো, ঠিক আছে? একটা রিপোর্ট বানাবে তো, তাহলে একটু পড়াশোনা করো, সেই অনুযায়ী দেখে নাও, সেটাই অ্যাসাইনমেন্ট। ওকে,
ওকে স্যার।
ঠিক আছে।